A pleasant day to everyone. My name is Escopete and I will be representing our group, and we will be discussing about estimation on plumbing works. So before we discuss the process of estimation the plumbing works, let us first discuss what is plumbing. So plumbing is the practice of installation of pipes, fixtures, and other equipment that distribute water supply in a building and dispose of wastewater in a safe way. So the purpose of water is to get water to a structure for the use of the occupants and to remove sewage and used or unwanted water from the building and its surrounding areas. So here are some examples of sanitary pipes and fittings. First, we have soil pipe. So this is a pipe through which the sewage discharge from the water closet passes. Then waste pipe. It carries liquid waste but not the toilet sewage. So example is the draining used water from the shower, bathtub, lavatory, and kitchen sink. Then we have vent pipe. So this provides air within the installation. Then another sanitary pipes are this one, the trap. This retain water at its curved section to block obnoxious sewer gases and prevent them from coming into the room. Then the stack. This is the vertical sanitary pipes extending from floor to floor or roof to roof. Then we have vent pipe through roof. This directs harmful gases in sanitary system up above the roof. Then coupling socket for joining two pieces of pipes without altering the direction. Then we have bend elbow, which facilitates the change of direction of the piping installation. Then a clean out with plug. This is attached to the dead end in a pipe draining waste. Then we have these different types of T. We have the T, the sanitary T, and the sanitary Y. These are fittings that allow a branch to be connected to the longitudinal or main pipeline. So here we are going to discuss the installation of sanitary piping. So a soil pipe with branches to the different plumbing fixtures and receptacles through the building to where the toilet bathroom is located. One end is a clean out with a removable cap to allow cleaning if the pipe gets clogged. Other terminates inside the septic vault, a receptacle where the waste from different fixtures are deposited to be drained off through the house drainage system to the street sewer or canal. So a pipe vent through the roof provides air inside the pipes through the vents to facilitate the easy flow of the waste, to avoid vacuum and to dispel the obnoxious gases inside the system above the roof. So that is the purpose of the vent through roof. So here we have the water distribution system. So the purpose of the water distribution system is to provide water to a structure. So the building water, so it starts in the water main, then go to the entrance pipe or the water entrance pipe, then along the street by means of a corporation cap. The amount of water passing through the water service is measured by the water meter. So this is the one that will measure the amount of water that we consume. So the meter shut off and the gate bulb located just before and after the meter respectively serve to control the entire building water service. From this, the water pipes branch out to the different fixtures requiring water. So the faucet or the shower, so those are the different fixtures that will discharge the water. So house drainage system. So concrete or CHB basins serves as receptacles for water deposited by downspout connected to the roof gutters or from groundwater overflows. Interconnected concrete drainage pipes empty the water from the catch basins into the street gutter, canal, or public sewer system. So this is isometric diagram of plumbing diagram. So in working drawing, so as we can see here, this this one, the line with two dots, these are the water distribution system. So it start at the main pipe, then to the water entrance pipe, then to the meter shut off, then to the meter, then this is the gate valve because these two are used to control the flow of water. So then it will branch out to the different fixtures. Example, the shower, then this hose bib, then this one, this broken line, this is the vent system of the plumbing system. So this is the vent through roof, it goes up to the roof, and the horizontal vent piping. Then lastly, we have the dark line, this thick line right here is the drainage system. So this is where the waste water will go. So here we have the pictorial drawing showing the meanings of the symbols used in the plumbing plan. So this is like the previous one is described more specifically and more detailed. So the acronyms have now meaning. So the HB is host bib. So like that. Then this is example of sanitary pipes and fittings for a sample 1-unit toilet and bath. So as we can see, we have steel vent, so that is important. Then the fixtures, the lavatory and the toilet. Then this is the drainage. So this is where the waste from either from the lavatory, the toilet, or from the shower heads will go. So these are examples of plumbing fixtures and accessories. So we have two water closets right here. Then we have lavatory. This is a lavatory still. Then we have urinals. Then we have a bathtub. So now let's move on to the estimation of plastic pipes. So currently the available pipes in the market are 3 meter and 6 meter. For the 3 meter pipes, these are hubless. So meaning its effective length is 3 meter, unlike the 6 meter pipe which have hub. So we will discuss that later on. So as you can see, face-to-face distance right here, then the engagement length. Engagement length is length allocated for pipe-to-pipe connection. So like that. Estimation of plastic pipes. So as we can see in table 1, this engagement length of 6 meter pipe. So we have different pipe sizes. Then these are the corresponding engagement length centimeter, then their effective length. So weight per meter in kilograms. So that 3 meter is not for the 3 meter pipe. We don't have no table for that because the effective length is 3 meter. So for table 2, quantity of solvent cement per joint. So we have size of fitting and their the length and their corresponding cement per joint. So how to estimate the number of pipes? So we have here an example. So for the number of pipes for this illustration below, using 63 by 3 meter plastic pipe and 100 millimeter by 6 meter plastic pipe. So this is the face-to-face distance, which is 44.40 meters. For the first example, for 63 millimeter by 3 meter plastic pipe, divide the face-to-face distance by the length of pipe. So 44.40 meter divided by 3 meters. So this is the effective length of the pipe, this one. So equals 14.8 pieces. Then since there is a remainder, we multiply that by the length of pipe. So we get 2.4 meters. Then we solve for the engagement length. So let's refer to table 1. So for the 63 millimeter pipe, wait. So for the 63 millimeter pipe, so we have 7.5 engagement length. So that's the engagement length. So 7.5. Then 15 cm or 0.15 is the result. Then add the values of step 2 and 3. So we have 2.55 meters. Then summary of order, 40 pieces 63 millimeter by 3 meter pipe. then one cut at 2.55 meters long. So we will cut 3-meter pipe at 2.55 meters. Then solve for the solvent cement. So number of joints is equals to number of pipes times multiplied by 2, since there are two tips of the pipe. Then 14 times 2 equals 28 joints. Solved cement equals number of joints multiplied by, so we just see for, refer to table 2 for the multiplier. Then what we have here is 5. 28 times 5 equals 140 grams of solvent cement. Then we move to this one, the 6-meter, the 100 millimeter by 6-meter plastic pipe. Divide the face-to-face distance by the effective length. So as we can see here, the 6-meter is, we will not use the entire 6-meter, but rather this 5.8 centimeter. So number of pipes, 44.40 divided by 5.8 centimeter equals 7.56 pipes. So still the same as for the first example, we multiply it by the 6-meter. 0.56 times 6 equals 36 meters. So we cut the pipe right there. One pipe of 6 meter right there. So solve the engagement length. So let's refer to table 2. So 14 cm times 2 equals 28 cm or 0.28 meter. Then add the value of step 2 and 3. So we have 3.64 meter. So for the summary of order, we have 7 pieces, 100 millimeter by 6 meter pipe. Then 1 6-meter pipe that is cut at 3.64 meters. So determining length of pipes with offset angles. So here we have ratio of offset measurements. So these are the different offset angles. Then the corresponding ratio of travel to offset, then ratio of run to offset. So we have right here an example. Find the travel distance of the pipe if the offset angle is 45 degrees and the offset length is 30 centimeter. So this is the length of the pipe, okay, 42.42. Then it is inclined at a 45 degrees angle. So 30 centimeters is the horizontal distance. So for the computation, we have travel length equals offset length multiplied by the multiplier at table 3. So we have 1.414 for the multiplier, and the travel length equates to 42.42 cm or 4.242 meters. So right here we have plastic pipe fittings used to connect pipes with one another. So these are like, this will connect the pipes together. So it can also change the direction of the flow or decrease the rate of flow. Change the direction of the flow like the T, the Y, the elbows. Then decrease are the reducers, like that. So here we have 90-degree thread T, reducing T's, 90-degree T's, 90-degree threaded elbow. So this will change the flow of water. So these are some examples. Then we have 90 degrees elbow. Then male threaded adapters. These are used to connect the pipes. And as well, we have female threaded adapters. Then we have unions, sockets, then reducing sockets. So this will make the flow of water constrained, or like that. Then cups. So it is used at the tip edge of the pipes, at the cups. Then reducing adapters. So now we're done at the estimation of plastic pipe. Let's move on to cast iron pipe. So the commercial length of cast iron pipe is 150 centimeters long, with diameters ranging from 50 millimeter to 150 millimeter, with the following types. So we have, first is we have the standard pipe. This is for well-fitted hub and spigot connections. Then we have single hub pipe. These pipes are more than 550 centimeters in length. Then the double hub pipe are shorter than 150 centimeters. Then we have the hubless pipe. These are used instead of single hub because it is cheaper and easily connected using a neoprene rubber sleeve. So that's the hubless pipe. Then let's move on to the measuring length of cast iron pipe. In measuring length of cast iron pipe, the end portion that will enter into the hub is added to the face length of the effective distance. So right here, we have the face-to-face distance, then we add the engagement, like that's. So for table 1, effective length of cast iron pipe. So we have here the pipe sizes in millimeter as well as in inches. Then laying length in centimeter. For the pipe with hub, so these are the values. Then for the hubless pipe, these are the corresponding values. Then table 2, additional length in cutting cut iron. So these are the pipe diameter, then these are the measurements, then engagement length. So that's it. So this is the example number 1. From figure 1, find the length of the cast iron pipe required using 75 millimeter, 3 inches diameter. So this is the illustration. Then let's move on how to solve it. So the solution. The length of the face distance is 120 centimeter. From table 2, the additional length for a 75 millimeter 3-inch pipe is 6.8 centimeter. So we have 120 plus 6.8 equals 126.8 centimeters. Then, so this is another example. From figure 2, find the length of the cast iron pipe required using 125 millimeter this time, 5-inch diameter pipe. So the face-to-face distance is 360 cm. From table 2, the additional engagement length of 125 mm 5-inch pipe is 7.5 cm. Thus, the two and engagement length is 7.5 plus 7.5 equals 15 cm. The total length required is 360 plus 15 equals 375 cm. Divide the length by effective length of one pipe from table 1, then under pipe with hub given is double hub pipe. The effective length is 142 centimeters. So this is the result. 375 over 142 equals 2.64 pipes. The whole number 2 means 2 pipes at 150 centimeter long. The amount 0.64 means the fractional cut to be cut or taken from one pipe. So in short, this is less than 1 meter pipe length. Therefore, the pipes required are 2 pieces 125 millimeter at 150 centimeter equals 3 meters. Then 1 piece 125 millimeter at 93 centimeter equals 93 meters, 0.93 meters. So the total length is 3.93 meters. So now we order 3 pieces 125 at 150 centimeter cast iron pipe. So cutting and connecting pipes. The procedures in cutting cast iron pipe is we use a chalk to mark cut lines on the pipe. Then the pipe is laid on the sand or flat wood. So using hammer and cold chisel, the marked line in the pipe is struck gently at first around, then continue striking harder and harder all around until the pipe is cut. Then caulking joints, quantity of oakum and lead in pipe joints for cast iron. So that is caulking joints. So this table right here is the quantity of oakum in pipe joints. So pipe diameter and their corresponding weight of oakum per joint in kilograms. Then table 4, we have quantity of lead in pipe joints. So the pipe diameter right here, then weight of lead in kilograms. So example, determine the quantity of oakum and lead in kilograms required for a drainage installation with the following joints. So 6 joints of 50 mm pipe, 10 joints of 125 mm pipe having 20 mm lead packing. So solution, refer to table 3 and 4. So for oakum, since there are 6 joints times 0.05, this equates to 0.30 kilograms. Then for the 10 joints, we have times 0.23 equals 2.30 kilograms. So this right here, the multiplier that is referred to table 3 and 4. Then for the lead, we have 6 joints times 0.50 equals 3 kilogram. Then 10 joints multiplied by 1.5 equals to 15 kilograms. So we will order 2.60 kilograms oakum and 18 kilograms peg of lead. So now let's move on to sewage disposal system. Sewage disposal system are systems with the purpose of collecting, treating, and disposing of wastewater in a building. So that the wastewater now is safer to dispose than for those that is not yet treated. So that is the purpose of the sewage disposal system, to treat the water, then dispose it safely to outlets like rivers or ocean. Then 4 types of sewage disposal system. We have cesspool, so we have a privy, then a septic tank, then public sewer line. Most commonly built sewage disposal system in the Philippines is the septic tank. So this is what is common in the Philippines for the CR, the septic tank. A septic tank is a receptacle for waste and wastewater. Solid waste suspended at the bottom. So in it, anaerobic bacteria processes the waste stored in the septic tank and decomposes it. So this is like the waste is treated by the anaerobic bacteria. So it's an automatic process. So that concludes our presentation for estimates of plumbing works. Plumbing works. So I hope you learned something new and bye bye.